unit has been a little bit more math only than some of our other units, and for those of you that are hoping for a little bit more real-world application, I'll tell you that this is the last topic in this unit that's really not story-based, at least somewhat. However, this is one of the most important skills that you will cover in Algebra 1 because you see this skill over and over and over again. I use this nearly every day, even up to my college classes. So that skill is called foiling, or what I like to call the double distributive property. Now, I'm going to tell you right now that when you go to high school, you are going to hear the term foiling much more often. Almost everybody says foil. I prefer the double distributive property for a very specific reason, and I will show you later in this video why I prefer this name. So, reviewing the distributive property, that's when we have a number on the outside of a parentheses, and we can rewrite the term inside the parentheses 3 times, or we can distribute the number to every term inside the parentheses and multiply. So, for example, this would be 3x plus 12, but the problem on the bottom is what we covered in the last topic or last section. So in this case, we would just get yx as a standalone variable plus the variable 6y. So this is the single distributive property. So you might be asking yourselves, well, where are we going to be using the double distributive property? So let's do a couple small examples of the single distributive property again, and I will show you what the double distributive property will look like. So this problem we did already is 3x plus 12. This problem is slightly different than what we did before. X times x is x squared, and x times 4 is positive 4x. Both of these are the single distributive property. Now, what if instead of 3 and x, we had 3 plus x in a separate parenthesis times x plus 4? The rule is that every single term in this parenthesis must be multiplied times every single term in this parenthesis here on the right, which means this number 3 must be multiplied times this x and this 4, which is what we did here on the left, and this x must be multiplied times this x and multiplied times this 4, which is what we did here on the right. So the double distributive property would say that 3 times x is 3x. 3 times 4 is 12. We've done both of these terms, so that number can now be ignored, and we do the second half of the distributive property. X times x is x squared, and x times 4 is 4x. So we have 2 terms times 2 terms, and we have an answer that has 4 terms in it. But usually when you're working with foiling or the double distributive property, you're going to have to simplify somewhere in the end. And I have 3x and 4x can be combined together to give me 7x plus 12 plus x squared, or like the last video, if we want to write it in descending order, we would write it like this. So that is the double distributive property. It's literally doing the distributive property twice. So that brings us to the question of what is foiling exactly? So for the problem here at the top, parentheses 2 plus 3y, close the parentheses, and y minus 3 in the second parentheses, if I was doing foiling, what that actually means is it's an acronym that stands for first, outer, inner, last. So for this problem, if I was doing foiling, the F would stand for the first term of both parentheses, 2 times y, which is 2y. The outer would stand for the outside terms that are farthest away from each other, 2 and negative 3, which would be negative 6. Inner would be the inside terms, or the terms that are closest together. That's 3y and y over here, which would be 3y squared, positive. And finally, the L stands for last, which would be this 3y and this negative 3. So we get negative 9y. Once again, we can combine like terms, which in this case is the positive 2 and the negative 9y. Writing my answer in descending form would be 3y squared first, negative 7y from simplifying these terms second, and negative 6 last. So that's what foiling is. It just stands for first, outer, inner, last. If I was doing the double distributive property, I actually end up getting the exact same steps and the exact same answer. If I distribute the 2 to every term in the other parenthesis, and then I distribute the 3y to every term in the opposite parenthesis, I get 2y minus 6. Whoops. That didn't go very well. 2y minus 6 plus 3y squared minus 9y. And I end up getting the exact same answer here on both sides. So, foiling and the double distributive property are exactly the same thing, but you are far more likely to hear foiling when you're in high school. So that brings us to the last question. Why does Mr. Schmidt prefer the double distributive property instead of the word FOIL? What's the difference? So let's show you why. So for this first problem, we have 4x plus 6 parentheses, x squared plus 3 parentheses. So let's do the double distributive property. So I'm going to distribute 4x to every term in the other parenthesis, and then I'm going to distribute the 6 to every term in the opposite parenthesis. I get 4x times x squared is 4x cubed. We covered that in the last video. 4x times 3 is 12x, positive. 6 times x squared is positive 6x squared. And 6 times 3 is positive 18. And that is our answer. If I wanted to write it in descending form, I would do 4x cubed plus 6x squared plus 12x plus 18, and nothing can be simplified in this problem. There we go. Double distributive property, that works fine. But what if I add one extra term to that second parenthesis? Now it's not a binomial times a binomial, it's a binomial times a trinomial. First, outer, inner, last only works when you have 4 answers. But if I'm doing 2 terms times 6, or 3 terms, I should get 6 terms as my final answer, and foiling no longer works. But the double distributive property still does. I distribute the x to every term in the outside parenthesis to get x cubed, here to here, plus 3x squared, here to here, minus 4x, here to here. Then I can do the positive 6 distributed to every term in the opposite parenthesis. So that'll give me 6x squared plus 18x minus 24. So foiling no longer works because foiling only works on a binomial to a binomial, but the double distributive property works on a binomial to every other possible polynomial. And you can then do the triple distributive property or the quadruple distributive property. So if you come up to Mr. Schmidt and tell him why he prefers the double distributive property, I will give you 5 SPs. Let's finish this problem though. So x cubed cannot be combined with anything else, so we write x cubed at the bottom. 3x squared can be combined with 6x squared to give us 9x squared. Negative 4x can be combined together with positive 18x, which is positive 14x. And then finally, negative 24 is just written here at the end as negative 24. And there you have foiling, or the double distributive property. Like I said, this is the last topic that will be really math only from here on out for the rest of the year. There should be at least some real-world applications for the rest of the topics we cover. As always, if you have any questions, please let me know.